So don't let how short this tutorial is fool you. It is a little complicated. I'll try to make it seem a little simpler. It's basically the Pythagorean theorem with added facts if the triangle is not a right triangle. Because I'm not sure if any of you have ever tried this, but if you ever enter cosine of 90 degrees into a calculator, you'll end up getting zero. And that's because you're saying that your cosine, the angle that you're doing right here, you want to do the adjacent over the hypotenuse. And this would end up causing it to be very strange. So you end up getting this zero because it's like, wait a minute, this shouldn't happen. There's a little more complicated things to that, but you don't get into that until you get into the unit circle. So for right now, just think about it as you're just not supposed to ever have that happen. All right, so let's get into proving this, and I will release a video shortly afterwards on how we're going to apply this. So proving cosine, proving law of cosines, and we're going to use we will prove the law of cosines and use them to solve some problems. The following tutorial has more problems where we're going to solve this. So basic idea here is we're able to use trig for triangles that are 90 degrees. That's where we've been doing the SOHCAHTOA. SOHCAHTOA, and how we've been able to use trig, inverse trig functions. In other words, these little negative ones, or as we see it in this calculator, arc sine or arc cosine. They're both the same thing, just different way of saying it. But what happens if our triangle isn't 90 degrees? Are we still able to use that? And that's where we're going to get into law of sines. Oh, we're doing law of sines and law of cosine. So apparently we're doing law of sines first. I was expecting cosines first. This is a very interesting one. So what happens here is if we have two congruent triangles, we're able to use sine to help us solve for another triangle. So when we're doing this, so we're going to do these processes through GeoGebra. So let's take a look here. So triangle one side, another angle. So here's our triangle. And the interesting part is law of sines actually works on the same triangle. So let's look, and we're only dealing with one triangle here. So they want us to calculate angle ABC using triangle sum theorem. So remember, triangle sum theorem is just this idea that all angles of a triangle equal 180. I should say sum of all angles of a triangle equals 180. So adding up all the triangles are going to equal 180. So if we're doing this, we're trying to find angle B. So we have this theorem that we've been using, which is essentially angle A plus angle B plus angle C equals 180 degrees. That's our theory, or our theorem, not theory, theorem. So angle A, we're going to replace it with 53.13 degrees. We're going to add our angle B because that's what we're solving for. And we're also going to add together 57.99 degrees. This is equal to 180 degrees. We're going to add those two together. We can just use the little Edmentum calculator. 53.13 plus 57.99 we get 111.12 degrees. There it is. Plus angle B. And that has to equal our 180 degrees. Probably could have typed it out by now instead of being lazy, but I don't like clicking on the degree symbol. Now we're going to subtract this number from 180. So 180 minus 11.2. So that's what this is. This angle B is going to equal. Got a 1. And I forgot my angle B. We're subtracting it from both sides. We get this. So hear this out. 180 minus 111.12 get 68, which is equal to 68.88. Cool. So that's that part. Can submit that. And it shows us they go more specific with it. I'm just like, it's angle B. We're only dealing with a triangle. We don't need to specify the endpoints. Construct B going through that's perpendicular to AC. Construct a line through B. Go perpendicular. So what we're going to do here is we need to make a perpendicular line from AC, and we want to make sure that it is right here exactly at that B. So just to double check this, because I've had issues with this in the past where it doesn't go where it's supposed to, I'm going to measure this angle because I've been scorned too many times. Oh, let's actually, now I remember why I've been scorned so many times. I've never marked this point correctly. A new trick that I picked up was this point of intersection. You might have seen me pick this up in the last video. I have this. So this should make it a little easier for me to be able to measure this degree, and it should be exactly 90 degrees. If it is not 90 degrees exactly, something went wrong. And apparently I'm really bad at clicking points. There, it is a perfect 90-degree angle. So if you get something like 89.99, go back and fix it, because I've tried to get away with not doing that, and it just means that you didn't mark the point correctly. So construct a point based on their angle measurements. What would you classify ABC and CBD? So ABD and CBD. Uh, so I would say both of these are right triangles. And it's mentioning the angles. So I'm wondering if these are. Oh, because of how it's set up, they should be similar, I think is what they're hinting at. But let's double check just to make sure. So I want to do angle B. So I want to do C. I want to do CBD, but I want to make sure I'm doing this counterclockwise. So clock goes this way. So I definitely want to do the A, then the B, and then the D. Okay, and then here I'm going to do, I want angle B, but I want to go counterclockwise. So I want to go D to C because I'm going counterclockwise. So I'm going to do D, B, and then C. And I'm going to move these around because it looks a little confusing. Okay. You can tell which one's which because they should only go a certain distance. So this one can't get any further. So that means this one's closer to this one. Okay, they're not similar. I was worried they might be hinting at that. They are both right triangles. Plain and simple. Yep, both right triangles. By considering BD is a side of that, express its length in terms of variables, side length, and angle measurements. Show your work. Considering BD is a side, express its length in terms of variables, representing side lengths and angles. I'm assuming what they're saying is so BD, I can say something like, um, let's see here. Well, here's a C and here's a BD. So if I wanted to say this, I could say that this is the opposite. So I'm going to say sine of the degree is this. So keep in mind, we're not supposed to know this angle. I took it upon myself to solve for it. Um, but let's kind of pretend they're not there for now, for the sake of this problem. Because you weren't supposed to do it. I just kind of did it just to double check to make sure anything else is going on. So sine equals my opposite. So that's going to be a fraction. So I'm going to put a fraction here. Opposite, which is line segment BD. So BD. And this is all over 10. So this is how I can represent this. I'm assuming that's what they're asking for. Let's see what they're, yep. So they're doing it with variables. I kind of plugged in considering side length, show your work, considering BD is the side length of that. Okay, so now that we know that I did this a little weird, I'm going to do it the other way, but this time I am going to use the variables. So I'm going to say that sine of C is equal to the fraction BD over our hypotenuse, which in this case is A. So I'm going to put little a. Oh, I see. I see how they're going to make us prove it. Now we're going to combine this to make them both fractions. So we have two variables here. We have BD equals a sine of C. And we also have this BD equals, we can go back up here to do it, C sine of A, C C sine of A. So I'm going to set these two equal to each other. So I'm going to use both parts from how Edmentum solved it. And I'm going to solve this as, let's see here, just to kind of write it all in. So A sine of C equals C sine of A. Now we want to divide it by both sides. So just to make this easier, I'm going to divide just the little side. So I'm going to do sine of C equals C sine of A. And this is going to be divided by little a. Well, I want this to both be fractions, so I'm going to divide both sides by little c. So I end up getting sine of big C, because it's the angle, over sine of little c. And now since we divided by little c, that sine of that little c is no longer there. Fraction. And I'm going to say this is of a over little a. So this is actually our law of sines. I hope this is as far as it gets with it, because you could do sine of b over sine of little b also, but I hope it doesn't get to that point. And it looks like we are. So keep in mind, they have it backwards, but the thing with fractions is if you flip them over, they're actually equal to each other. So let's say I did something like, I don't know, 1 over 5 is equal to 2 over 10. And let's say I flip this over, 5 over 1 is equal to 10 over 2. This is true because 10 divided by 2 is 5, and 5 divided by 1 is 5. So if you have two fractions equal, you can flip them over. It's totally fine. So now use the formula part E to calculate the decimal place of this. So we're going to use the formula to calculate A. Calculate A. Oh, this A. I see what they're doing. All right, so we're going to use this formula here, sine of C. So give me a second. I'm going to use the formula I wrote instead of their formula. So I'm going to say sine of C over little c equals sine of A over little a. Now, from here, I'm just going to plug everything I know in. So sine of, and I'm going to use my angle, sine of 57.99. And I'm going to divide that by little c, which is 10. And this is going to equal sine of A. And my A is 57.99. And this is all going to be over little a. So this is where writing it upside down comes in handy. So, all right, sorry if there was an awkward pause there. I got a call from another teacher in the middle of this. Okay, so when we're doing this, what we want to do is, oh, shoot, I did. It's a good thing that did stop me because that should be 53.13. Oh no, this is supposed to be 53.13. All right. So this is, like I said, this is the part where writing it upside down comes in handy because we want to solve for a. So the first thing we want to do here is we're going to flip both fractions over, which makes this, also going to rewrite it that way, get a on the other side. So I'm flipping them over. That's the main thing, and I'm changing directions of which it's an equal sign. Of course, you can change directions. It's totally fine. 10, and this is sine of 57.99. So you can see how this got flipped over and I moved it over here. This got flipped over and moved it over here. Now what I want to do is I want to solve for a. So I'm going to say a equals, I'm multiplying both sides by this sign. So I end up getting a fraction 10 sine 53.13. And I'm going to put on the bottom, I'm going to put sine of 57.99. Now it's important to know that some students see this and they're like, oh, this means multiply because it's in parentheses. It actually is an argument. You put it in here and the function of sine kind of solves it for you. So what I'm going to do here is I'm not a big fan of how small you guys have this calculator here. So I'm going to use an actual scientific calculator. I'm going to use the Desmos scientific calculator. I feel it is a little more um, comprehensive. It's more of a comprehensive calculator. So here I can, normally I'm able to copy and paste, but unfortunately the Edmentum doesn't go in well with this. So I'm going to say sine of 53.13. And be careful because when you change tabs, Desmos for some reason thinks that you went over to somewhere else. And you're going to divide it by sine of 57.99. And I'm going to get 4.93 as my answer. So I'm going to say this is equal to A equals, what was that? 9.43. I misspoke. 9.43. So I get that as my answer. Submit this. 9.43. Cool. So I actually went right on there with Edmentum. So looking at this, now we're going to go to another one. So based on the angle measures, classify ABE and CE. Okay, so construct a line that's perpendicular to BC and okay. So unfortunately, we are doing that thing that I mentioned that it looks like we're gonna have to redo this. So I'm gonna go back here. I'm gonna clear all of this out back to how we were before, where I can't do anything else. And now I'm gonna drag this tab closer. I'm gonna make a line that is perpendicular to BC and intersects at point E. So label a point of intersection at E. Construct a line through point C or point A perpendicular to, okay. So construct a line BC. So I'm going to do another perpendicular line. Perpendicular line. Click here. The point we want it to be perpendicular to is right here. We need to label the intersection. So we're going to do another point of intersection between this line and this line. And it labels it right there. And it asked us to label it E. Oh, I guess we could have kept all the other things that we had. Oh, well. So let me deal with that right now. So now we want to label that E. What would we classify this? So we're going to classify them as both of them being right triangles. So this again, I should just copy and paste that. They are both right triangles. And our goal basically is um, to prove law of sine. So that's why we keep using right triangles because as of yet we only know how to use trig functions using right triangles. So considering EA as a side of this, express it in terms of, okay, so we want to say EA. So if we're doing EA in terms of sides and angles for angle AEC, oh, I'm going to rename this now. There we go. It, I didn't really rename it. I just clicked a point and it did it again. So yeah. So in order to do this, I mean, it did the job. In order to do this, we're going to use some variables here. So we're going to say that we're looking at EA. EA. So we're going to say that sine, just use the equation editor. I don't know why Edmentum didn't put this down as an equation editor already. Sine of 57.99 equals, oh, wait, sine, they want us to use variables. I learned that from last time. C, and this is equal to AE, our opposite. So do our fraction, AE over our hypotenuse, which in this case, I'm just going to put little b there. So now I want to solve this. So I'm going to say that AE equals B times, I'll put the little time symbol, times, since I'm actually doing it the way Edmentum wants me to do it, sine C. So that's our EA. Now they're going to want us to do it for the other triangle. I forgot to submit all of these. There we go. I need to do it for the other triangle, which this is considering that EA is part of the other triangle, this triangle over here. We're going to say that sine of B, so do the equation editor, sine of B equals EA, EA over little c. We're not going to actually use the 10. It wants us to use variables, so we're just going to say little c. So this ends up being AE equals little c times sine of big B. So now we have those. And now they're going to want us to do the same thing we did in the last problem, but they want it to be two equal ratios. So what I'm going to do here is I'm going to say, grab the first one. Actually, you know what? I'm just going to copy. Nope, they thought of everything. I can't copy that. So I'm going to say little b sine of big C equals little c sine of big B. So you can see why we use lowercase and uppercase when we're talking about sides and angles, just because you know which one this is just by looking at it. It's a lowercase, so that's a side. It's an uppercase, so that's an angle. Now, what we're going to do here is I'm going to copy this and go into the equation editor. This, put this in the equation editor. And then what I want to do is I want to divide both sides by little b. Grab these, put a little division sign there. I'm going to put a little b right here. And then because I am lazy, I'm just going to copy and paste this. I honestly think this just is more efficient to copy and paste it. You know, you're not doing any mistakes. Do this, underline, or make it a fraction. I'm going to divide both sides by little c. So I divide this by little c. Dividing this would cancel out this little c here. And now we have this law of sines right here. And I don't know if I'm pretty sure it's still back. Yep, it's still backwards. Do they want it with the sides on top? They don't specify how they want the relationship. Again, you can flip it over. I have a feeling I'm going to regret doing it this way again because of how they're making me solve it. Use the equations you just had to solve this. I'm just going to grab this, just copy this. So in case you guys wondered what I just did there is I highlighted everything I just did with the equation editor and then went into the equation editor. So this allows me to just go into this equation editor and then I'm just going to paste what I just copied. But now I'm going to replace my variables. So angle C was 57.99. I'm going to do 57.99. Let me see something. Let me check something out. Calculate B to two decimal places. It's interesting because they didn't tell us to solve for angle B, but obviously we do need it. So I'm going to grab that here. Oh, wait, we did solve for it. Duh. We solved for it way back when. 68.88. I totally forgot we had solved for that using whatchamacalled, sum of angles of a triangle. So sine of B was 68.88. We know what little c is because it's given as 10. So now we're going to multiply both sides. We're going to flip everything over. So we have 10. And I'm going to flip everything over and multiply. You guys saw how I did it. You guys can rewind if you feel you need a refresher on that. that, and I'm going to divide all of this. So I'm doing a couple steps here. All of this by sine of 57.99. And this is all equal to my little b. So that means that little b equals, I'm going to go back to Desmos. Sine of 57.99 is luckily still there. We're still multiplying by 10. And we're going to do sine of 68.88. And I'm getting 11 as my answer. So I get 11 there. Boom. Let's see how good I am at this one. Yep, approximately 11 units. Now we're going to combine the ideas that we learned here. One of the ideas we learned too was, stop it. There we go. So we have sine of little c, sine of that, sine of big. And then we see here that in part A, where's my part A? Part A, part E, little sine over c is equal to that. So we end up getting this expression when we combine them that states sine of big C over little c equals sine of big B over little b. And because of the transitive property, if that's equal, we can also say that sine of big A over little a. And of course, we can always flip these over if we want. So we're combining those ideas here. And you can also flip them over to have them like they do. Construct a line perpendicular to this based off the angle. Are we really going to do it again? Yep, they're really having us do it again. They love the repetition of it. All right, so construct a line through point B that is perpendicular to AC. So I'm gonna just use the same triangle. I don't want to have like a million angles there. Perpendicular to AC going through point B. Didn't we? We did this already, right? We we did this already. Is it really gonna make us call this point D again? Based on the measurements, we're gonna say the right triangles. Okay, this is weird. It is literally the same thing. I wonder if this is a typo. Considering this, write it. This is considering that. Show your work. I wonder if this is a mistake because it looks like all of these are exactly the same. Oh wait, okay. So part F looks a little different. Okay, hold on. Calculate. Combine the two expressions you found in part B and C to relate it to this. Show your work. Okay, hold on. Let's combine. I'm going to look at part D for the first one. Part D. Considering this. Considering. Let's take a look here. Considering. I'm gonna go ahead and do these because I think it's gonna be more work to figure out what the differences are than to actually just do the work at this point. So that being the case, what we're gonna do is literally do what I did earlier. We're gonna create a perpendicular line. Boom, boom. And how can we? So Instruct express the length in terms of the sides. Oh, okay. So BD express the length in terms of the sides. Show your work. So this one we actually now know. Um, wait, do we know this? We don't know what this length is. Oh, they want us to solve using trig. Okay, so that's the part that's different. So we're gonna say that sine of 53.13 is equal to opposite, which is BD divided by, I got tired of doing um, the thing, so I'm going to do this over 10. So in other words, BD equation editor. That was the word that I was looking for. 10 times sine of 53.13. So in other words, BD equals, they want us to round. Oh, they just want us to use variables again. I'm going to finish solving this and I'm just going to copy and paste it. They want to the next one because I know that's what they're having us do. They're just slow rolling us, which I really wish they wouldn't. It's too much work to slow roll at this point in time. So we're gonna do 10 times sine of what was it, 53.13? Yep, 53.13. Enter it. I get about 8. So I got about 8. So about 8. Considering the representing side using angles. Considering BD show that representing show your work. I don't even know what they want us to do there. Or I do know what they're wanting us to do there, but hold on. Considering BD is representing side lengths and angle measures. Combine parts B and C. Okay, here we go. So I'm going to show my work here. They are really slow rolling this to a snail's pace. Let's see here. Considering BD as a side length of this. Oh, I see what they're doing. Side length of this triangle. We already did this. Oh my gosh. We already did this way back over here. Considering that we want to use the variable. So it's this idea right here. So I'm just going to write it as such. Sine A. Oh my gosh, where are we? So they want us to do sine A equals BD over little c. BD over little c, which means that c times sine of A. All right, and then they want us to do it again over here. So they want us to say that that's BD. And then we're going to say that BD equals, I don't know. You know what? This one I think we did do correctly over here. So I'm literally going to grab this. Oh, they're doing BD instead of AE. This, wait, wait. BD. We did that here. I just forgot the second step. So CBD. Triangle CBD. There we go. Which means this is going to be A times sine C D equals BD. Oh, you know what? I should probably submit this so we can see. Yep, exactly the same thing we did in the previous part, which means this is going to be exactly the same thing we did in the previous part. Yep, combine them to show our work. So we're going to scroll all the way up to part one because I don't know why. We're going to grab all that. Oh, I think they're literally just going to make us do it, but they want us to do it the other way around. Okay, hold on. Submit that. Yeah, now they want it. Oh no, literally the same thing as before. I have no idea what they're doing here. Calculate angle C. So we still haven't even done this. So in this case, they want us to calculate angle C. Oh, I see. Um, Before we calculated it using, we calculated this angle. Why angle C? We already have angle C. Well, I guess because we already have it. That's why they want to solve for it. Okay. So the annoying part is, oh wait, I see what they're doing. All right. So yeah, we have C. We don't have little a. So I guess we have to use the little a from before. Use the equation in part D. Okay, we don't have part A, so thanks for that. Um, I guess they're assuming we have part A, but we haven't solved for part A. They never told us to solve for part A. Hashtag not bitter at Edmentum for bad directions. Okay, so now we have part little a. So using that, we're going to use the formula. So we don't, we're going to pretend we don't know sine little c for whatever reason. Edmentum wants us to do that, even though it should be asking us to solve for little a just to show proof. So we're going to pretend we don't know that. We are going to underline this. Little c is 10. This is equal to sine of b, which sine of b we solved for. I'm just making sure, yep. Calculate sine of c. I feel like they should have said sine of b, but okay. Sine of b, so we're going to calculate angle b. Underline that. We didn't know what this was until I plugged it in, so I'm going to do that. And then we have to plug in the angle that we calculated for it. So then we're going to say that sine of c equals 10 times sine of 68.88, 9.73. And in order to solve for c, we have to use sine inverse. So we do this. I'm going to hit the little sine inverse button over here. And we get a fraction in here. It looks like a lot of work, but this is why I like using the calculator on Desmos, because I can actually plug all of this in Desmos and it be not a problem. All right, this is 9.7. So in other words, angle C equals whatever all of that is. So that, and you're going to divide all this by, this is 68.88. And we're going to divide all this by 9.73. Hit the enter button. Oh, sine inverse. I almost forgot the sine inverse part. Sine inverse. I just use the little like keyboard functions, but you can click the little sine inverse thing here. I'm gonna put all of these. Oh, you know what? They get really picky. So I'm gonna put the closing parentheses here. It puts the whole thing in parentheses. There we go. So I want this whole thing in parentheses. And I end up getting 73 points. What am I missing here? Okay. So little c was 10. Little b. Little b. It would help if I actually did my correct little b. I did little a instead of little b, guys. I'm sorry. Little b is really 11. Oh, we had just solved for that. That explains it a little bit more. I was like, wait a minute. I don't think we ever solved for little a. Okay, that should definitely fix this. Okay, and it's 57.99, which we already knew was there. They were just going like, hey, this should work. So now this is saying like, calculate B using this theorem. Did you already do that? Edmentum, watch your typos. I'm guessing what they meant to do was they intended for where is it? What is it? Yeah, I have no idea what they were trying to do here because here they're solving for little c. They got 40. Is this another triangle? If they oh they had another triangle here, guys. Oh well, I'm gonna keep doing this the way I was supposed to. I wasn't supposed to, but um, on the other one because I did not see that link. It is super well blended, and I am really bad at seeing those links. So I'm sure if I look at this, it's totally different. Yep, completely different. So follow those directions. That way you can see this a little better. Because I was under the impression we were still doing the same one. So I'm going to submit it. If you use this, that's fine. You're literally doing the same thing, just with a different triangle. So now it's like similarly, we want to get this using the relationship. All right, so now we want to solve for little b. And you know what? That makes even more sense because remember I was saying like we don't have little a. Let me calculate little a or little b. We didn't have little b, so let me calculate little b. All right, so similarly, we're going to construct a line perpendicular. So this time I will use the right triangle. That's what I get for not reading directions. I'm going to construct a line. Construct a line perpendicular to BC that passes through point A. So again, perpendicular line BC, which is this passing through point A right there. Cool. And now we're going to construct this. So we're going to use a similar relationship, but this time they're like, hey, we gave you the formulas, just solve for them. So I'm not sure why we had to construct the line then, but okay. Solve for side B, side little b. So let's plug in everything from the formula. This is what they should have done for the other stuff. So we're gonna plug in everything from the formulas. Like, why are you making us calculate formulas we've already calculated, Edmentum? Come on now. We know what angle B is. Angle B We said we're going to use their angle B, which is 71.94, is equal to little c. Little c was, what's their little c? Their little c is 12.08, and their sine of c, so they don't give us our angle c. So I guess I was right. Edmentum doesn't provide all of the information when they need it. We need to go counterclockwise. So if I need to go counterclockwise, what I need to do here is I need to measure this. So I want to go from D to A to go counterclockwise. And I get 42.51. So sine 42.51. I'm going to multiply both sides by this. So I get B equals 12.08 times sine of 21.94. Gonna put all of this over sine of 52.51. All right, gonna calculate all this in to my Desmos. 12.08 times sine of 71.04. All of this divided by sine of 42.51, and I get 16.9. So B equals 16.9. And let's submit it to see how close I am. They wanted it to the nearest whole number? They said 2 decimal places. This is Edmentum being its Edmentumimus. So from D, can we derive anything from part G? How can we define the relationship of the angle measures opposite of this? Uh, this is just a proof of what we have already said in part 2. They were gonna do a lot more, but they're literally saying the exact same thing over again. I'm gonna say part 3 was not necessary. We already proved it. We already proved this. So I know Edmentum usually causes us to do more proofs and they slow roll things and all of this, but this one I felt took way too long. So looking at this, um, we're just using this. So this is the law of sines. You can say the side over sine of the angle, sine of the opposite angle, is equal to another side divided by the sine of the opposite angle, and vice versa. So that's how you can say this. If you want to write this down, I recommend it. I think it is in the guided notes. So I do always recommend the guided notes. That way you have this written down. So you're going to put your little a here. You're going to put your sign of your big B here. And you're going to put your little c here. That way you have this in your notes ready for later. And if you look here, they even give you the reasoning for this. Oh, I wonder if this is going to come in handy for our next slide. So Here we're going to calculate if the measurement, so let me use some of my drawing tools here. So the measurement of angle B, this is 36 degrees, and the measurement of angle C, this is 75 degrees, and we want to solve for side little b. And they did give us side little a, by the way. I didn't mention that, but the side little a is a 12 centimeters. So when we're writing this, we want to write it down as, if we're solving for b, we want little b to be on top. It's always easier to have what you want on top here. Then sine of 36, which is what we got over here. I don't know if you guys can see that. It's a little hard for me to see. I should have picked a better color. And that's going to be 12 over sine of 75. And we can rewrite this to become b equals 12 times sine of 36 over sine of 75. And we're all going to type this into here. So 12 times, what was that? Sine of something? Sine of 36. Sine of 36. All of this is over sine of 75. Sine of 75. So here's our answer. We're going to want to go and plug that into our answer. So little b. So we have this here. And they want us to do two decimal places, which is 7.30. So 7.30. Done. Edmentum, how did you calculate it? This is the part that kind of stinks, is round off error is a big factor when doing this. Edmentum is probably not calculating it with the proper round off error. So I'm not going to know what they have. So what I'm going to do is 36 sine that. I really hate how they have to do it this way. Then I'm going to multiply. So I did sine of 36 right now. Then I have to multiply this by 12. So I'm going to multiply this by 12. Then, here's the nasty part. I have to write this down to save for later. 7.05 divided by whatever sine of 75 is. So I have to clear this. This is a very inefficient way of doing this Edmentum. I hate this. 75. I'm going to do sine. So I'm going to be dividing that by 0.97. So let me go back over here. 7.05 divided by 0.97. I get 7.27. Still wrong. Edmentum, I don't know what you want me to do. I'm using law of sines correctly. Sine b over sine of 36. And then, oh, this is little a. Derp. Well, I have egg on my face. So they want us to solve for the missing angle first. Edmentum, don't do this to people. Nobody likes it. You're making this harder for no reason. So this is still 36. This is 75. But I hadn't realized that they hadn't given me angle A. So if I add these two together, I get 111. 111. So if I take that minus this, why are you doing this, Edmentum? This is not worth it. This is going to be equal to That would be 79. 10 less would be, so this is 69 degrees. So my angle A was 69 degrees. So angle A wasn't 75, it was 69 degrees. And I get 7.56. 7.50. Ah, come on. 7.56. 7.56. My num block was acting up on me. So we had to solve for angle A because we didn't have that to use law of sines. Moving on to the next one. So now that I know Edmentum's plane mean, it's like we've already know how to do that Edmentum. That's not the standard that we're testing for right now. Little a is 16. Little b is 10. Angle A is 42. And you'll notice they don't do this with the sides because they're like, oh, that's too hard. Um, Now we want to solve for angle B. So in order to solve for this, I'm going to want to put sine of angle B on top of, and we want to do little b. So like I said, this one, they give you all the information you need. The other one, they were just being mean for the sake of being mean. Sine of 16. Wait, not sine of 16. Whoopsie. I got used to putting my sides on top. Sine of 42 over 16, which means we have 10 times sine of 42 over 16. All right, so let's do this. Sine of 42 divided by 10. 10. Maybe it wasn't letting me because I was saying the wrong thing. 16 uh, times 10. We're going to hit enter on here. And that cannot be right. Oh, sine inverse. I almost forgot. We have to do the sine inverse of this. I was like, that can't be right. It's a decimal. Duh, because sine inverse takes a decimal and gives you an angle. Come on, Victor. I think they drained all of my energy from those tasks. All right, so we're going to do this. Hit enter. We get 24.72. So here, 24 point. I wasn't. Come on, Edmentum. Obviously, I didn't want to just leave it there. I get it. There we go. So I prematurely hit other keys. I think just out of frustration. Let's see here. All right, so we're gonna do law of sines next. So you're probably gonna see a difference in the clock because I'm gonna step away from the computer because law of sines is a really tough beast to tackle. All right, so let's get into law of cosines. This, as I mentioned before, is going to be very, very similar to the Pythagorean theorem. So, oh, and of course, Edmentum logged me out. I'm going to take that as a sign to make this a two-parter. Since I don't have editing software, it's going to be very difficult for me to edit together. So, this is going to be a two-parter, guys.